Hi, welcome to the third BCH coding tutorial. So let's pick up where we left off last time. So we provided a list of 3 hard-coded commitments, and from this we converted it with the libas library to NFT number and rendered the corresponding image. So we're well on our way to make something like this, which features the recently minted NFTs. But here, these are just hard-coded values. So we need to add support for a network library, which can actually fetch the data from on the blockchain. And for this, we'll use the Electrum cache library. So to ask the Electrum servers for the history of the minting contract, so we can know which are the recently minted cash ninjas and what the block height of those transactions are. So that's our next step, to actually have the block height displayed and to get this with the Electrum cache library. And my end goal for the project is not to exactly recreate this app, because it already exists, but to make something new, namely for the Reapers project, where the SBCH NFTs are going to be bridged over to cash tokens. So it would be nice to have an app which can show the Reapers that have been bridged over. So that's my idea for this project. But let's first move ahead with the basic features to get it closer to this state. So we'll import the Electrum cache library, and we do this by using the npm install command. So let's move to our terminal, and we, like last time, have the thing running on localhost with npm rendev. And then here we can run the command npm install Electrum cache, which will take a while. And then we can see here how to import this, but the import syntax uses require, which is not supported by our environment, so we need to change this. So we can just easily test this if you would use at the top require and then go back to our application and see in the console it says require is not defined. So we can't use this syntax. Instead we need to do import like we did before, import the Electrum client, and instead of require, import it from the Electrum cache library. So now if we refresh, the errors are gone and our app displays as we intended. So to move along, we will initialize our application and we'll follow the documentation. So we connect to the server by using these commands. So by using Electrum equals a new Electrum client with a bit of configuration, and then we await the connection. So we can just use that here in our onMounted function. And if we save and go back to our application, then it gives us an error. And I contacted the devs to ask why following the default documentation would result in this error. And this is because it's meant to be used not in the browser. So if you want to use it in the browser, you need a bit of special configuration. And I've got it right here. So we need the Electrum transport layer to provide extra configuration. So if we import the Electrum transport layer from the same library, we can see that the Electrum transport layer has a few options. So we need to use WSS and not one of the others. And to do this, we need the extra configuration of the Electrum port and the scheme. So we can just add it here. So we use the WSS port and the WSS scheme. So if we then try to save this and take a look at our application again, that we will see that our application loads without any errors. So now we can test something with these, we can test getting information from the Electrum servers. So we can do this by just copying the example again. So we could declare a transaction ID and we request the full transaction. So we provide the request, which is transaction.get, and then we provide the transaction ID, and then we wait for the Electrum server to give us the full transaction in hex. So if we copy this and paste it into our application after we connect it, so this is just to test whether it is working, and then we get the full hex of the transaction back, which is this whole string. So we now know it is working. So we can delete this again. So now we have connected to the Electrum application. So what do we want to do? Well, we want to display the current block height. So to do that, we'll jump into the code And here we'll add a div, so just a basic element, which can say current block height, and then it needs to have the current block height, which will be a dynamic element. So let's actually create that, a constant called block height, which will be a reference because it's dynamically updated, and we can initialize it just like this, just an empty reference, and then we can display the block height here. So if we save this, of course this will just be empty and we don't update it anywhere. So if we go to our application and we take a look, then it's actually here in the right hand side, but we would want to have it below the rest of the text. So what we need to do is we change a little styling, namely the styling here of the wrapper element. So we could either remove the wrapper or just remove this part of styling. So because it used to be a flex element, which means it's in line, in the same line, but if we remove the flex, it's below it. And now we want to bump the font size a bit, so it's the same font as the text above it. So we can do that instead of by making a default div to create a h3 element and also update the ending tag. So then if we save again, we see that it is the same font as we used above. So next up, let's get this block height. And if we go back to the documentation, we can subscribe to notifications like this. And here, conveniently, they use the subscription to the block headers, and they listen for the updated block headers. So we can just use the same code. So we'll copy the things at the bottom and then rewrite the function at the top. So here, after we are connected, we say when we get a notification, handle the notification and await for the subscription and subscribe to the headers.subscribe. So what is this handle notification? Well, it's a function that we can write ourselves. So we will do that. We will just say function handle notifications like that. And then it receives some data. So, and the data looks like this. So it gives the JSON IPC, the method, the parameters, and in the parameters, we can find an array with an object which gives the height and the hexadecimal of the block header. So let's just console log this information and see if we receive it correctly. So console log the data and head back to our application, open the log, and then if we wait a second, we can see here that indeed we received an object with JSON IPC method parameters, and then here we can find the block height. So we want to update the block height. So if we want just the block height, we would say the data, we want the parameters. Then this is an array, so we want the first object, and then we want the height. So if we just do it like this, console log it again, and then wait for the application to reload, we see this number, 822,257, which is the same as we see here. So this is the current chain height. And let's actually display that at the top in our application. So we would update this reference. So we would say block height.value equals our new value. So for this, we can create a variable called const current block height, like that, and then paste what we had before, and then we can both console log this information and set it equal to the block height that we update dynamically. So now if we let it refresh, we can see the current block height displays correctly, which is nice, which is what we wanted. So the next step is to actually get the minting contract of the Cache Ninjas and get the relevant the contract address, so we can hide code this. So if we go to a new tab and we do ninjas.cache, here we can see that at the very bottom there will be the smart contract address, which we can copy paste, and we can set here in our application. So we would use const mint address equals, and then we can set the long address, and then this doesn't need to be in the handle notifications, and it's not. Okay, so at the bottom, mint address, and then we want to write our own call to Electrum cache. So something like this, something like the transaction get, but not quite it. So we could copy it and call it just a const response. And then what do we request? Well, let's actually take a look at the documentation, at the methods. And I think it's called get history. Yeah, get history. So we do blockchain.address.getHistory. So this is the call we need. So blockchain.address.getHistory, and then an address. So we provide a mint address. And then we have a response. So we want to console.log that response. And we expect an array with a ton of transactions, because the history of this minting address will be very large. So let's actually save this, get back to our Vite view application, and refresh. And now we see that the block height is not displaying. So let's do a full refresh. And here we have the block height correctly rendering and the whole history, which is an array of 1432 items. So a very long array. So we need to split this. So we only have the most recent 5 elements. So we would call this, for example, recent mints, and we can parse this array to the response by doing response.slice and getting only the latest 5. We can do this with a negative element called by providing a negative element, and then it will give us the latest elements of that array. So let's log them both so we can compare and wait for our app to load. So here we have an array of 5 elements like we wanted, and we can see the very latest one ends with 17FF. So we go to the very long array, and there take the very last one, we also see 17FF. So we have successfully parsed the array, which is good progress. So then we see that this only provides the height and the transaction hash. So we want something more, namely we want all the token data. So we need this call, the blockchain transaction.get method, but we don't want the transaction hash. Instead, we want a destructured transaction object. So let's take a look. We can here provide an option called verbose, and it says when verbose is false, it returns the hexadecimal. Otherwise, it returns this kind of nice object where we can get the token information from the specific transaction. So that's what we'll use. We'll set the verbose to true, and we'll use that call. So we can copy this call and provide it here at the end. And we want to do this for each transaction. So we can say for transaction, let's do const transaction of the recent mints. So for const transaction of recent mints, and then we want to do this. So we want to have all the transaction information. So this is a transaction, let's call this tx info. And we want to add the verbose equals to true. So this would be the transaction ID. So we call const transaction ID of recent mints, and then we provide true, and then we console.log this transaction info. So now is the more technical part of actually parsing all the responses and getting the commitments, the commitments from the blockchain itself, and not just hard coding it. So if we take another look, we say invalid transaction hash, of course, because this is an object. So we would need to say, so this is an object, so we need the transaction hash, so transaction underscore hash, because otherwise it provides the whole object. So back to this, so it was right to call this transaction and not transaction ID, and then we need transaction.transaction hash, like that. And then refresh to get a clean console and see whether it's working. And this is what we wanted. We wanted the full object. So let's take a look at one of them. And we want the outputs. So these are in the object called Vault. And here we see token data amount 0, NFT, commitment BF06. Let's see if you also see this one here. So it doesn't match perfectly. So we'll need to look into that. So we have the BF06. And let's take a look at one of the others. So again, the object, the vouts, we need to check the first vout, I remember, because the first one, so maybe that was my error. We checked the vout 0, but we want to check vout 1, because this is actually the minted NFT, whereas the first output, so the output at index 0, will have the minting NFT. So here it says commitment A606. And if you see here, A606 is also not in the, so we will need to check whether this is the correct information. But it seems to me that we can at least start parsing this info, and that this is just behind. So let me refresh. Oh, A606 is actually just a recent mint with only 6 confirmations. So let's get this info. Let's get the commitments from our array. So now we have the full info, but instead of console logging the info, we want to provide a new array. So we say const maybe commitment mint of mint recent commitments, something like that. Is an empty array, and then we'll push to this array, and we need to push the recent commitment. So maybe push NFT commitment, and then of course we need to define it. So the NFT commitment will be the transaction info, but then we want to parse it. So if you remember, transaction info, and then we first go to the vault, and then we selected vault 1, and then once we're in the vault, we selected, so this is an object, we wanted the token data, and then once we have the token data, we want the NFT object, and then if we have the NFT object, we want the commitments, like that. So let's first log it to see whether it actually works. And refresh, so we get an empty terminal, and now we get A606. So this is exactly what we wanted. So instead of providing the list of commitments at the top, we can remove this, so no longer a list of commitments here, which also means our ninja list here is, let's think about this. So we want to remove this, so our reference here in the ninja list will be empty. And then we can update the ninja list. So you want to set the ninjas.value right here. So the ninjas.value equals a no ninja list. Or just a ninja list altogether, because we'll remove the one at the top. So we'll remove the commitments, and then we need to copy paste this over. And the ninja list, it's used to loop over the list of commitments, and we can still do that, but we need to rename this, so a list of commitments. And now it should all work. Only thing is, ninjas.value, this is not a function like this. We need to set it equal to the ninja list. So let's check one more time. We initialize an empty list. Then for each commitment in the list of commitments we just made, then we will show the ninja list. So it will be a little slower, but let's take a look if this actually works. So we refresh, we're doing all kinds of stuff in the console, and then we log all the recently minted ninjas. So we get all the same ninjas that we see here on this web page. Oh, excuse me. So it works as intended, only we have some side scrolling going on, but we can fix that quite easily. So let's do that right now. Just fix the side scrolling. We fix the side scrolling by going to here. It says display flex, but we need to wrap it. So it is called flex wrap, and then we just want to wrap it around. And then if it refreshes, yeah, we see them all 5 like this. So it's cleaner probably to have 6 of them. So we can easily change this number to 6. And then then we will get one more NFT to display. So like this. Or if you want 2 rows which end at the very end, we could make the NFTs displays slightly smaller. So the NFT item, we could add a display to the image, which is style with like 200 pixels. Try again. And then we have them way smaller. And now it's only 1 row and a half. So we would say, for example, 8. You want to get the 8 most recently minted ninjas. And there we have it. So these are the 8 most recently minted. So this is the most recent, and this is the 8th last minted. So maybe we want to reverse the order. So I think we can just call reverse. Let's see what this does. So if we call it like this, reverses the elements in an array. So we want this one to be the first. Let's see if this reverse works. Yeah, and it works as we hoped. So the last things I want to add, of course, what's missing still is the block height, but also we can just do the styling a bit better. So to finish off, let's change the background color to something nicer, like this blue, for example. So we can do that by going to the inspector, just selecting this color, then going back to our app, to the base CSS, and here we see the background. So currently it's white, so we change the background color to this. Let's see if it works. And it works, but now we can't read the text anymore. So we would have to change the text. So here's the text color, and we can just say this needs to be white. So like this, so the text color and the header both can be white, and let's see if that has any effect on our site. So now it displays as we wanted. So well, I would say that's it for this tutorial. We were able to use the Electrum Cache library right here and browse the documentation, which is also linked here. So the Electrum Cache documentation at electrumcache.protocol.readthedocs.io. We were able to use this library to get information from the Electrum servers, and we just used the default pch.imaginary.cache server as an example client, and we got from it the block height as well as the information on the most recently minted ninjas. And then we used a function that we already had, so we just moved this part of to construct the list. We just moved it around from the start of the application with a hard-coded ninjas list. We moved it around to the very end inside our onMounted function. And as you see, it all works. So very glad to end the third tutorial here, and we'll keep expanding on this in the next ones. Thank you for checking it out. Bye bye.